Welcome to part 6 of this series of presentations about the best ways to convert aliphatic alcohols into alkyl chlorides. This presentation is about the direct conversion of alcohols into chlorides by treatment with sulfonyl chlorides. Because of the low cost and ease of handling, sulfonyl chlorides are potentially attractive deoxychlorinating reagents, but unfortunately only reactive alcohols are suitable starting materials, unless extremely reactive sulfonyl chlorides are used. Upon reaction with alcohols, the first intermediate formed is a sulfonic acid ester. With aromatic sulfonyl chlorides, this is often a slow reaction, unless some base or catalyst, for example pyridine, is added. With methane sulfonyl chloride in the presence of triethylamine, however, sulfonate formation is extremely fast, because of intermediate formation of a sulfene. If the displaced sulfonic acid is highly acidic, for instance perfluoroalkane sulfonic acids, or if the alcohol has a high tendency to form carbocations, for example allylic or benzylic cations, then displacement of the sulfonate by chloride will be fast. Thus, only reactive alcohols are suitable starting materials for this reaction if the inexpensive methane or toluene sulfonyl chlorides are to be used. In order to catalyze the sulfonate formation, bases such as pyridine, DMAP, DBU or triethylamine are sometimes used. And as with other deoxychlorinations, a high concentration of chloride, attained for instance by addition of lithium chloride or quaternary ammonium chlorides, can increase the rate of alkyl chloride formation. If no spontaneous formation of the alkyl chloride occurs, the initially formed sulfonate may also be isolated and converted into the chloride in a second step, for example by treatment with chloride in a polar aprotic solvent at high temperature or with titanium tetrachloride. In this example, a bis-allylic diol was converted into the corresponding dichloride by treatment with methane sulfonyl chloride. The reaction proceeded at room temperature and without allylic inversion. Treatment of unprotected amino alcohols with deoxychlorinating reagents sometimes leads to the formation of aziridinium cations. If ring fission by nucleophilic attack can give two different isomers, it can be difficult to predict which one will be formed. In this example, I would have expected chloride to attack the sterically more accessible methylene group or a benzylic position, and not the more substituted aziridinium carbon atom. Nevertheless, a clean, high-yielding substitution occurred at the most highly substituted carbon atom, what suggests that this carbon atom had already some carbocationic character. So, what can go wrong? Most aliphatic alcohols will not yield chlorides upon reaction with tosyl chloride or methane sulfonyl chloride, but instead the sulfonates. Mesylates are, by the way, similarly or slightly more reactive toward nucleophiles than alkyl chlorides and can be used as electrophiles instead of the chlorides. Alcohols that readily undergo elimination, for instance those with electron withdrawing groups in beta position, may also yield olefins upon treatment with bases and sulfonyl chlorides. Then, sulfonyl chlorides can also act as electrophilic chlorinating reagents, in particular if the corresponding sulfonic acid is highly acidic. Such highly electrophilic sulfonyl chlorides can also oxidize tertiary amines to enamines, just like phosgene or trifluoroacetyl chloride. Here are some more examples, but only few instances of this reaction have been published. Compared to the other deoxychlorinating reagents presented in this playlist, sulfonyl chlorides are the least generally applicable and versatile reagents. If the target chloride is, however, to be used as electrophile, then the starting alcohol may as well be converted into a mesylate or tosylate. In particular, the preparation of mesylates by treatment of alcohols with methane sulfonyl chloride and triethylamine in dichloromethane is a simple and high-yielding method for converting aliphatic alcohols into electrophiles. In addition to the reagents presented in this video playlist, many other reagents can convert alcohols into chlorides, but most are of little practical value. A twofold excess of chlorotrimethylsilane in the presence of some catalysts can also be used as deoxychlorinating reagent for even unreactive aliphatic alcohols, and some examples of this reaction are given here. Other reagents include the combination of thioethers with chlorinating reagents and mixtures of cyanuric chloride with DMSO. In these reactions, as in most reactions involving DMSO and some electrophile, methylthiomethyl ethers and other byproducts can be formed, which can be difficult to separate from the target product. Some of these byproducts have a very intensive smell, so that even trace amounts can ruin the quality of a product. Moreover, these byproducts often poison noble metal hydrogenation catalysts, and iminium chlorides or phosgene are therefore better options for most applications. Some geminal dichloroalkanes can also be used to convert aliphatic alcohols into chlorides, by the mechanism shown here. These reagents work best if the dichloroalkane can dissociate into a stabilized carbocation chloride, for instance benzylic, cyclopropanilium or tropylium chlorides. These can react with alcohols in the same way as iminium chlorides do to yield an alkyl chloride and a ketone.